Alright guys, welcome to our spring semester review. This is page 3, and here we are using matrix to solve for systems of equations. You can do this straight through the calculator. If I were you, I probably would write down the steps just to refresh your memory so you know how to do it, okay? Remember to find your matrix. You go hit second matrix, right click to math, there's your determinant. Alright. And for your inverses, you're going to click -1 right here. Alright, so right now we are going to do systems using matrix. So before you do it, there's a few things you need to know. Make sure all your x's line up, all your y's line up, so it's the equal sign, and so is your constant. So A, B, C, okay? And then you're going to write it as a matrix. So it will look something like this, straight across. -3, 9, -3. Remember, matrix is all about order, so don't be sloppy. 6, 3, -15. If you notice, I just brought down all these numbers. If this one doesn't exist, you will put a 0 in its place, okay? You guys remember row echelon, row reduced echelon form, RREF? That's what we're going to use to solve for x and y. So you would hit second matrix, right click to math. So you are going to go to second matrix, go to math, okay? Scroll down till you see RREF. Alright. Or go up, your choice. Not REF, but RREF. Hit enter. Alpha zoom. This is a 3 by 2. Oh, I'm so sorry, I lied. That's a 2 by 3. 2 rows, 3 columns. Okay, so enter your constant or your coefficient, -3. I'll get that right. It's a coefficient. Make sure you type in correctly and push your enter. Do you notice how your answer is 1, 0, -2, 0, 1, -1? So that means this was your x, this is your y, this is your answer, okay? So x, 1x is equal to -2. No x, 1y is equal to -1. You can write it like this, or you can write -2, comma, dash, -1. These are ordered pairs, coordinate points. So if I graph this line and I graph this line, it's going to cross right there at -1, -2. Okay? Go ahead and write your matrix, -2, -3, 9, 1. There's an understood 1, 6, and 0. Same thing. Second matrix, right click to math, scroll down until you see RREF. Not REF, but RREF. Enter, alpha zoom, 2 by 3, -2, -3, 9, 1, 6, 0. So x is equal to -6 and y is equal to 1. So they're going to cross at -6 and 1. Oh, I don't know what happened there. My fault. Okay. So I'll stop for a little bit, give you guys a chance to write that down. I don't know what happened to the screen. Alright. So let's look at the word problem, okay? Here we go. A game show host says that he has $5,000 in 50 bills and 100 bills. Our $50 bill, we're going to call it X. Our 100, we're going to call it Y. And he will give you $5,000 if you can tell him how many of each type of bill he has. He gives you a hint that he has 73 bills. Use an inverse matrix to find out how many each of those have. Alright, so we got two things. We have a $50 bill and we have a $100 bill. I'm going to name this one X and I'm going to name this one Y. Okay? So you start off by saying I have $50 bills and I have $100 bills and I have 73 bills in all. Do you guys see that? There's a $50, there's this bill and there's this bill, and if I just count them, I have 73 in all. Alright. It goes on to say that I have a $50 bill. So 50x. So if I have one bill, it's 50. I have two bills, it's 100. 50 times 2. 3 bills is 150. 50 times 3. Plus my $100 bill, same concept except with a $100 bill, and total, if I count the value of that, it's worth $5,000. So I would go 100, 200, 300, 400, all the way to 5,000. Whereas this part, I'm going 1 bill, 2 bill, 3 bill, 4 bill, okay? Now that you have your equation set up, you can solve for it easily. X lined up, Y lines up, Y equal sign lines up, and the numbers lined up. So my matrix would look like this: 1, 1, 7, 3, 50, 100, 5,000. Okay? And like before, I'm going to use RREF to solve for each one of these. So, clear that. Second matrix, right click till you see RREF. Enter. Alpha zoom, a 2 by 3, 1, 1, 7, 3, $50 bill, $100 bill, value worth 5,000. Okay. See how they make a diagonal? Okay, an identity. So it says X is equal to 46 and Y is equal to 27. All right. So what does that mean? That means he has 46 $50 bills, 27 $100 bills. And there you have it. Okay? So it's just a word problem. You guys can do this. All right, let's go ahead and go to number 16. Let's do another one. Okay. Kara compares 3 fruit and nut gift packs. Write the matrix equation and solve to find the cost per pounds of pears, pecans, and nectarines. So she's got all these. So the 3 things she has are pears, pecans, and nectarines. I'm going to call this one A, this one B, and this one C. Okay? So I know which one is which. For the taster pack, she has 1.5 pounds of pears, 1.5 pounds of pecans, and 1.5 pounds of nectarine. Okay? And all of that is value at $22.50. Your favorites pack. You have 3 pounds of pears, so here's pears. And 3 pounds of nectarine, so it's over here. And 1.5 pounds of pecan. And all of that equals $39. Alright. The family pack. I have 3 pounds of pecans, so here's pecans. And 3 pounds of pears, so it goes over here. 4 pounds of nectarine, and when I add that all up, the value of that is $51. Alright, so now you have your 3 equations. Oop, that should say A. My apologies. All A's, all B's, all C's, and all constants lined up. Write your matrix. Notice I'm just writing the constant or the coefficient. Boy, I'm having issues today. 3, 3, 4, just like that, at $51. Okay? Go to your calculator. I'm going to clear this real quick so you guys see it better. And I'm going to type in this matrix using RREF. All right. Second matrix, right click, go down to RREF. Enter, alpha zoom. This is now a 3 by 4, 3 rows, 4 columns. Okay, so I'm going to type this in, 1.5, oops, 1.5, 1.5 for $22.50. 3 pounds, 1.5, 3, $39. Okay, make sure your number's correct. 3, 3, 4, 51. All right, do you see how you have your diagonals right here? Good. So here's your pears, here's your pecans, here's your nectarines. So A is equal to 5, B is equal to 4, and C is equal to 6. So it says, per pound, find the cost of the pears, pecans, and the nectarines. So the pears is worth $5. Pecans is $4. And then your nectarines is, the cost is $6 per pound. And there you have your solution. Not bad. Just remember, it's straight calculator, but you gotta know what buttons to push. I will not be helping you on your semester test to remind you of that. So write down the steps if you have to. Have a great day.